Om Sri Sai Ram. Hearty welcome to Sri Sathya Sai Lok Seva Gurukulam online classes. The topic is light energy. Now all of you are in full of energy, right? Other day I told you to do some meditation, Jyoti meditation. You practiced? Please do it. Taking Jyoti to all parts of the body. You can refer Dhyanavahini of Sathya Sai Baba. Very interesting it is. You practice that. That Jyoti, if you experience that is which is inside us, same Jyoti is in all of us. Birds, animals, all other human beings, you can think of the same Jyoti. So that is what is said in Upanishads. Tamasoma Jyotirgamaya. So, O God, lead me from Asatoma Sadgamaya, untruth to truth. Tamasoma Jyotirgamaya, from darkness to light. Mrityorma Amritangamaya, from death to immortality. O God, lead me. Okay, with this prayer and good thought, let us start the lesson, okay? I think all of you ready with the writing materials, pen, book, etc. Get ready. Okay, so before we come to today's topic, we'll just revise what we have studied in the previous class. We studied about reflection of light and loss of reflection. And light is a source of energy. Which is a natural source of energy? Sun. Continuously giving source or light energy everywhere. One more thing, sun is also called God, because the sun rays falls on all particles, human beings, plants, birds, rivers, mountains, every creature in this earth are illuminated by sun and equal to all. No partiality. These are good people, these are not good people. Nothing like that. So we also must be like sun. Paropakarartham idam shariram. Okay. With this introduction, we have seen the important law of reflection. And how does the reflection take place? That is by the help of a mirror. And there are some laws of reflection, that angle of incidence is equal to angle of reflection. Incident ray, reflected ray, the normal at the point of incidence, all lie on the same plane. They are the two laws of reflection. And we have seen some other interesting facts about mirrors. That any object kept in front of a mirror will undergo what is called as lateral inversion. Is it not? That means if you raise a left hand, in the mirror you see it as right hand, and vice versa. Means if you raise the right hand, you look as if it is left hand. And the distance from which you stand in front of a mirror, same distance, the reflection also will be there within the mirror. So they are some of the laws of reflection. And also you have seen the formation of images in plane mirror and spherical mirrors. And mirror is a opaque substance having a shining surface. When you say mirror, there are three. Of course, there are some more also. One is called plane mirror, and other two are spherical mirrors. Under spherical mirror, you have convex and concave mirrors. And also, convex mirror is one, which is bulged at the center and thin at the surfaces. Concave mirror is one which is hollow at the center and bulged at the surfaces. And also we have seen the formula, what is called mirror formula, 1 by V plus 1 by U is equal to 1 by F. What is U? Object distance. What is V? Image distance. And what is F? Focal length. Is it not? And also we have seen about sign convention and about magnification. M stand for the ratio of the image distance to the object distance. And these are to be measured from the pole. The distance are measured from the pole. Is it not? So, mirror formula, just now I explained you. Magnification means the size of the image formed. Is it equal to the object, less than the object, more than the object? And in one case of a concave mirror, you don't get image at all. That is when the object is at the focal point or F. And these are the things you already seen. And one more interesting point of light is refraction of light. And example in nature. Example in nature is what is called as rainbow. And what do you mean by refraction? When a ray of light passes from one medium to another medium, the direction of the incident ray changes. The change in the direction of light. That is what is called as refraction. It is because of the change in the medium. When you say medium, there will be two types, denser medium and rarer medium. In denser medium, you have the particles at larger distances. Denser medium, you have all the particles packed. In rarer medium, all the particles at a distributed. Is it not? For example, if you take air, air will be the rare medium, or you can say denser means you have glass or water when compared to air. These are called denser medium. So when a ray of light changes, passes through glass slab or a prism, it changes the direction of movement. So these are things we have studied in the previous class. Is it not? Now coming to home assignment, first question, a ray of light travelling in air enters obliquely into water. Does the light ray bend towards the normal or away from the normal? Then you must tell why it is so. And the answer is, a ray of light travelling in air entering obliquely into water, it bends towards the normal. Air into water. What type of medium is air? Air is rarer medium. Water is denser medium. So when a ray of light passes from rarer to denser, the ray of light bends towards the normal. What do you mean normal? Normal is a perpendicular line drawn at the point of incidence. Because air is rarer medium, water is a denser medium. During refraction, the frequency of the light remains unchanged, but its wavelength changes, and hence the speed of light also changes. We have formula V is equal to n lambda. This is already studied. V means velocity of light. N means, N also you can write, or you can write F also. Both are same. You can write F lambda also. N or F stand for frequency. And lambda stands for wavelength. And V stands for velocity. So velocity of light depends upon two things. One is frequency, another is wavelength. Now during refraction, frequency remains the same. This remains the same. Whereas if lambda will change, wavelength will change. Because wavelength changes, velocity also changes. And that is why the bending takes place. Okay? These are the things you already studied, and just the answers for the home assignments. Coming to second question. Refractive index of diamond is 2.42. What is the meaning of the statement? So refractive index is defined as a ratio of the speed of light in vacuum to the speed of light in medium. So we will call it as N. Sometimes they call it as mu also. Refractive index. So speed of light in vacuum. So we call it as speed of light in vacuum. This ratio and speed of light in the medium. Speed of light in medium. So here when you say the refractive index is 2.42 means it means the speed of light in vacuum is 2.42 times more than speed of light in diamond. Okay, that is a ratio, and that is the meaning of the word refractive index. So this is 2.42 is times more. That's why diamond is one of the costliest article in the world. In Sanskrit there is a quotation, Vajradapi katorani mruduni kusumadapi. So you have to be very strong like diamond. What is another specialty of diamond? You want one more diamond to cut the diamond. You cannot cut the diamond by any other substance. So be strong whenever difficulties come, or whenever there is something wrong going on, should be strongly protesting it. Be like a diamond, it is said. And Baba says, diamond is mind. If you dye the mind, then you get diamond. To get the diamond, you have to dye the mind. Means you should forget the mind. Okay? So here this is the meaning of the statement. Now coming to third question. A concave mirror produces 3 times magnified. So M is 3. Magnification. Real image of an object placed at 10 centimeters. So magnification is 3. This is minus 10. Why you must write minus 10? Because sign convention. All the distances are to be measured from the pole in case of mirror, and all the distances in line with the incident ray, in the direction of incident ray, are to be taken as positive. Here it is minus because you have to measure the distance from P to F. When you measure it from P to F, it becomes minus 10. Is it not? So that is why you take it as minus 10. Question is, where is the image located? Where means distance. They are asking V. So formula is very simple. V by U, that is equal to magnification. You may note down. You can take capital M or small m. V by U is equal to 3. V by U means how much? Minus 10 is 3. Therefore, V is equal to minus 30 centimeter. Image distance is minus 30. What do you mean minus 30? You have to measure it from P. From P. That is in the direction opposite to the incident ray. That's why it should be taken as minus. Okay. Now let us see today's topic. Laws of refraction. In the previous class we have seen the meaning of refraction, examples refraction. Now today we will see the laws of refraction. The first law says the incident ray. What do you mean incident ray? The ray which enters the medium is called incident ray. And refracted ray. What is refracted ray? The ray which gets refracted in the medium, maybe water or glass or whatever it is. That is called refracted ray. And the normal. Normal means what? Perpendicular line drawn at the point of incidence. All lie on the same plane. Of course, you will understand clearly after the experiment. That is first law. Second law is ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant and is equal to refractive index of the medium. It is also called Snell's law. Snell is a name of a scientist. Suppose you discover something, your name will be there. Suppose Sheshu discovers one law, then Sheshu's law, it will be called. Some name of the scientist who discovered will be coming. So it is called Snell's law. So refractive index N, sometimes they use the word mu also. Sine of angle of incidence to sine of angle of refraction. That is what is called as refractive index. Now this word sine may be a new thing for you. If you have studied trigonometry, you will know it. What is sine? The name of the angle. In trigonometry, what is trigonometry? Trigonometry is a branch of mathematics which deals with the measurement of triangles. Trigon, meter. Trigon means triangle. Metry means measure. And what are you measuring? Suppose this angle is, we call it as usually theta. There are so many constants which you are using for measuring angles like theta. What is this called? Alpha. Then you have beta, gamma, like that. It continues. You can use delta also. All these are different notations used for measuring angles. Here we use the word theta. So what is sine of an angle? Sine of an angle means we call it as base, we call it as height, and this is the longest side in right angle triangle, and that is called hypotenuse. Hypotenuse. So in right angle triangle you have the longest side and we call it as hypotenuse. So using these we can define 6 ratios about which you are going to study in trigonometry chapter. Suppose you call this as the base as x, perpendicular called as y, hypotenuse as r. Then sine of angle theta will be Height also you can call, I can call it as, usually they are called as opposite side. This is called as opposite side. Why it is called opposite side? Because it is opposite to the angle. That is the meaning. So sine of angle theta is equal to y by r. So what is y by r? Y by r means it need not be only y. You can call by any name. You say opposite side by hypotenuse. So that ratio is called sine. So here sine I means sine of the angle of incidence. Sine r means sine of the angle of refraction. Okay. This ratio is called refractive index. And different substances will have different refractive indices. Plural of index is called indices. Okay. For example, diamond has 2.42. So each substance will have different angle of these refractive indices. Now let us see a small activity. You can try with that. So a bucket is to be taken. A bucket of plastic is taken, filled with water. So here is your friend. He has taken a plastic bucket. This is his beautiful face. And he has kept his face inside water. And you can see a red bulb here. How can you see the bulb? Whether he looks it as red or blue or green, what is that? For his surprise, he will see the red bulb as red only. If you take yellow bulb, it looks at yellow only. Here you can see three mediums. One is water, another is glass, third is air. So here there is no change in the red color because the frequency does not change. When light goes from one medium to another, only its speed and wavelength changes. Wavelength changes. Wavelength of air is different. Wavelength of water is different. Wavelength of glass is different. That changes. But its frequency does not change. And when you say frequency, color and frequency go together. So color is the function of frequency, not the wavelength. Means any color bulb you put here, same color can be seen inside him. You can try it, okay? But you must take a transparent bucket, not green bucket or blue bucket, etc. Only transparent you must take, okay? So that is the thing. Now we will see the meaning of the word lens. We have seen an experiment last time about glass slab experiment, is it not? Similarly, now we see one step ahead about lenses. Lens is a portion of a transparent. Means what? You can see from one side to another. Can you give one more example? Yes, you can say plastic. You can say water. All these are example of transparent refracting medium bounded by two surfaces. So it is actually a part of the globe or sphere of glass, and it is cut such that one of the surface is bulged, and you have convex lens and concave lens. Convex means bulged at the center. I am telling about double convex. So bulged at the center. And concave lens means hollow, or you can say No, concave. Cave at the center. You can say hollow, but bulged at the surfaces. They are the two types of lenses. You can see the figure also now. Say concave lens. It's also called converging lens. This is an example for double convex lens, it is called. Why it is called double? Because this surface also bulged. This surface also bulged. So this is double convex lens. And this is also called converging lens. Why it is called converging? The ray of light coming parallel. Where do you get parallel lines? You can get from the sun's rays. So when sun's rays fall on a lens, they pass through, after refraction, they pass through a point called focus, also called as principal focus, or also called as focal point, denoted by the symbol F. And what is that you are drawn here? It is called ray diagram. Why it is called ray diagram? Because you get rays here. And when you say rays, you must know different kind of rays. This is called principal axis. It passes through the optic center. And these two are called incident rays. And this is called refracted rays. Okay. So this is the point where it touches the lens. And this lens is called converging lens. Of course, you may say, give an example which you are using daily. Daily you are using, in Kannada we call it Booth Kannadi. And in English it is called double convex lens. Okay. And you might have seen it. It is having a handle. Suppose you keep it in a sun rays, you might have seen it. At a particular distance, it will be, refraction. After refraction, it passes through a point. Have you experienced it? Yes, some of you. No? If you take a paper, it can make a hole in the paper. And if you have a hand, it will give you a lot of heat at that point. Any other burning substance, if you keep, it burns off. That is because all the rays after refraction passes through a point, and that point is called principal focus or focal point. Okay. And coming to the next type of lens, that is called concave lens. So it is bulged at the surfaces, but it is hollow, you can say, or cave type in the middle. So here light will come parallel to the principal axis. After refraction, it appears to come from the focal point. So this is a focal point here. It appears to come. Actually, it goes deviated. Why does it deviate? Because it is refraction. Why does it go into refraction? Because this is the air medium, this is the glass medium. The ray of light enters from rarer medium to denser medium, its direction changes. What is the property called? Refraction, right? So here it gets deviated, and if you just produce the other side of the rays, it appears to come from the principal focal point, also called as focus, and usually you write it as F. Okay. So a concave lens has its two surfaces caving inside. Caving means what? Hollow, other word. Okay. So this is called caving. Concave. This is convex. and it makes parallel rays of light to spread and from a point. Hence it is called diverging lens. Diverges means goes out. The previous one was called, look at the difference. The previous one was called converging lens. Look at the difference now. This is called converging. Here rays after refraction passes through a point. Now we are seeing diverging lens. It goes away from the normal. Okay. So it has two surfaces caving inward. It makes parallel rays of light to spread from a point. Hence it is called diverging lens. Like this it goes away. The point where from light rays appear to diverge is called focus. This point is called focus. Okay. And let us see how the images are formed in lenses. And there are different cases here. The two rays required to draw the image formation. The rays, they are called as ray diagrams. Come on, all of you get ready with a pencil, scale and compasses. Okay, I'll teach you how to draw it. So you must remember how to draw this ray diagrams. First of all, a ray parallel to the axis of the lens converges after refraction at the principal focus of the lens. Now we are discussing about only convex lens. So one of the ray which comes parallel after refraction passes through F. Or in case of concave lens, they appear to diverge from the principal focus. Okay, that is the first ray. Second one, a ray of light towards the optical center falls on the lens symmetrically and after refraction passes through it undeviated. So there is one line in the middle which gets undeviated, it won't change. That is second ray. Third one, so this is some of the cases where it happens. First one, you must draw a principal axis. Now your doubt will arise, how to draw this? First draw using pencil and scale. Come on, all of you get ready. Draw a line of 10 centimeter. Drawn. In that, mark a middle point at 5 centimeters. Call it as O. Then, to the left side, you mark the point F1 at 2 centimeters. And on the right side, mark it as, suppose you call it as F1, you can call it as F2 or you can call it as only F. Okay, so just 2 centimeter left side, 2 centimeter right side. And then in that point O, draw a lens. How to draw a lens? Take a compass at F1, mark a, draw an arc. To cut that arc, you draw one more arc from F. And these two cut at a point here. Then you get what is called as convex lens. And now the case is, object is between focus and lens. And this is where you have to see. This is observer, means your eye. So it is kept between O and F1. This is the focus, this is object. So O is called as, it is called as optic center. The center from which the lens is made up of is called optic center. So between O and F, if you keep this object here, O means object, and image will be, suppose you name it as AB, please draw it. The image will be, say, A dash, B dash. What is the nature of the image? It is erect. Erect means as it is. Where it is formed? It is formed at F1 and it appears to form. It is a virtual image. What difference between real image and virtual image? Real image you can catch in the screen. Virtual image you cannot catch. Now how to get it? You can see inside the lens. Okay. So these are the nature. Size will increase. Suppose this is 1 centimeter, it will be 2.5 or 3 centimeters. There will be increase in length. Okay. And coming to the second case, object is at first focus. If you keep the object at F, one ray comes parallel to the principal axis, after refraction passes through F. Second ray passes through O. The point of intersection of these two will give the position of the image. And in this case, you cannot get the image, or we call it as infinity. Image is formed at a large distance. And the refracted parallel rays meet at infinity. That means they don't meet at all because they are parallel to each other. These two rays are parallel to each other. And means you cannot join it here, the other side. So that it is the second case. First case is between O and F, virtual image. In this case, there is no image or it is formed at infinity. And coming to third case, object is between F2 and 2F2. So left side we call it as F2 and 2F2. What is F2? Focal. 2F2 means center of curvature, or just double of this. How to draw this? Draw a line of 10 centimeter as usual. Middle point you call it as O. 2 centimeter this side F2. 2 centimeter this side 2F2. 2 on the right side F1. Again 2 from here to F1. Now object is to be kept between F2 and 2F2. This is the object. So how to draw the lines? One ray parallel to the principal axis. After refraction passes through F1. Second ray passes through O. And these two rays meet at a point called I. I means what? It is an image. Suppose AB is the object and after refraction we get the image called A dash B dash. What is the nature of the image? It is real. Means what? You can get in the screen. And size of the image, it will be bigger in size. Okay, nature, size, position. Where it is formed? Beyond 2F1. Beyond 2F1. So because it is between the two, you get beyond that. Okay, that is the third case. Coming to fourth case, if the object is 2F2, that is C, center of curvature. So here object is kept here, one ray coming parallel, after refraction passes through F. Second ray passes through O. The point of intersection of these two is called the image. And where it is formed? It is formed between F1 and 2F1. So if you have a 2F2, you keep it on 2F2, it will be formed at 2F2, F1 only. Exact size. Size is same. Position also. This distance O2F2 is equal to O2F1. Both will be same. Same distance, same size, but it is real image. You can get in the screen. You can try with the convex lens at a candle. You can try. Beautiful, images can be got. So that is the fourth case. Coming to fifth case, beyond 2F. Suppose you keep it beyond 2F. The object is here. One ray coming parallel passes through F. Second ray passes through O. These two meet at a point called here between F and 2F. And it is real image, inverted, and size is smaller. Okay, and that is a fifth case. Sixth case is object placed between O and F. So in this case, rays coming from the object at infinity. So when the rays are coming from infinity, then the image will be formed at F. All of them will pass through a point called F, and that is how you got it. That is what I said you in the beginning. Suppose you have a convex and keep it in the sunlight, all the rays coming parallel will pass through a point, and that is called focal point. And these are the different cases in which the images are formed. This is a real image, and coming to concave lens, there is only one case. Wherever you keep the object, the image will be, virtual. Image will be erect, and the image cannot be caught on the screen. Okay, these are the nature size of the concave mirror, concave lens. How to draw it? First this PQ is a object, a ray parallel to the lens appears to come from, so get deviated because it is concave lens. Second one passes through O. The point of intersection will be the position of the image. This image is virtual, erect, and smaller in size. Size also is smaller. So these are the different cases of the formation of images in the convex lens, and now it is concave lens. Okay. Now with this information, we write it in a table form. So all this image form a different position of the object and nature of the image can be summarized in the table. So what does the table give? Same thing what we tell now, it is in the form of a table. You can note down this. Between F and pole, pole means P, here it is O. Okay, and image formed is in front of the lens. It is virtual and direct, enlarged, first case. Second case, if the object is kept at F, you cannot get the image, but we call it as infinity. How to write it? Use the symbol. Real and inverted, highly enlarged. You cannot get in the screen. Between F and 2F, if you keep it, is beyond 2F, real inverted, enlarged. At 2F, image also at 2F, real inverted, same size, very beautiful. That sign is very, very beautiful. You can try it with the convex lenses. Beyond 2F, if you keep, image will form between F and 2F, real, inverted, smaller in size. If you keep at infinity, means long distances. If you keep, all the rays pass through F, real and inverted, highly diminished, means point. Image will be point. And for concave lens, there is only one case. Anywhere in front of the lens, if you keep it, and the image will be formed between F and pole. Pole means here optic center. And image will be virtual and erect. Erect means as it is. And it is always smaller. Okay. So the position here is between F and O it forms. So these are the different what we have explained in the earlier. We will put in a table form just to make it clear. Okay. You can note down. And now you must know the sign convention, which I already explained now. For in case of spherical lenses, the distance in a lens are to be measured from optical center. What is it called? O. Either in the left or the right. The first thing. Second, distance measured in the direction of the incident ray are taken to be positive. in the direction of incident rays. What do you mean incident rays? Incident rays are the rays which come and fall on the lens. That is called incident rays. So, all the distances in the direction of incident ray are taken to be positive. And third one, distance opposite the direction of incident ray are taken to be negative. That is the rules. It is called sign convention. Okay. And in case of size of the image, height of the object on image measured above the principal axis, please add the word axis, otherwise it refers to the principal's height. Sir, our principal is 5 feet 2 inches, 5 feet 4 inches, we say. Not principal's height. Here principal axis. So image size of the object measured above the principal axis are taken positive, and whereas below it are taken negative. Okay. So these are what is called as sign convention. Means while drawing figure, while working out problems, you should know this sign convention. And there is a very important lens formula. As you had a mirror formula, here also we have a very, very important 1 by f is equal to 1 by v minus 1 by u. What is u? Object distance from the optic center. And what is v? Image distance from the optic center. What is f? Focal length. For convex lens it is positive. For concave lens it is negative. And how do you say positive, negative? Because we are measuring from the optic center. Okay. So this is a very, very important formula. Please note it correctly. On the basis of this only we have to work out some problems. Okay. And one important thing, as you have studied in mirrors, we have also got magnification, means size. Size of the image to that of the object is called as magnification. For example, magnification lens m is equal to size of image, you call it as I. Size of the object, that you call it as O. It's also equal to V. What is V? Image distance. What is U? Object distance. They are same. So that is what is called as magnification. Sometimes we say the size is same. Size of the object and size of the refraction, the size of the image is same, we call it. Then we say suppose the size is 10, object also is 10, then magnification becomes 1. Okay. And suppose the image is say 5 centimeter, object is 5 centimeter and image is 10 centimeter, then you say magnification is 2. Okay. So there are different cases, depending on that you have to write the magnification. And where V is image distance, U is the object distance. Okay. Now we will work out on two simple problems. The size of the image and object are equal in a lens of focal length 20 centimeters. So f is 20 centimeters. Name the type of the lens and distance of the object from the lens. Okay. So focal length is 20. Size of the image is equal to size of the object given. And then the object has to be kept at the center of curvature. You remember the case? Center of curvature is also called as 2f1 or 2f2. Sometimes they call it as C also. So if you keep at C or 2f, image and object will be the same size. Here focal length is given to be 20, and this happens only in case of convex lens. So lens must be convex, and the distance will be 2 into 20 because 20 is the focal length into 2. So this is called 2f. So 2 into 20 becomes 40 centimeters. That is the distance of the object. So if you keep the object at 2f1 we call it, the image will be formed at 2f2. So the size is also same, distance also is same, and the lens is convex lens. Such things will happen only in convex lens, where the two sizes will be equal. That is the answer for the first question. Coming to second question, a 2 centimeter tall means magnification is 2. Height of the object is 2. Perpendicular to the principal axis of a lens of focal length 10 centimeters. So focal length is 10. The distance of the object from the lens is minus 15. Find the nature, position, size. So focal length is 10 centimeter given, and height of the object is given to be 2 centimeters. Now they are asking, and object distance is minus 15. Focal length is 10, object distance is minus 15. Why it is minus? Because it is the reverse direction of the incident ray. How do you measure it? From O. And question is, what is image distance? Is the question. So you have to use the formula. So what is the question? One more question is height of the image. Height of the object is given. Height of the image is asked. So formula is 1 by V minus 1 by U is equal to 1 by F. Now you have to find out V. So we have to find out V, is it not? So keep V on one side. Though you can just transfer the formula. So to get that V, shift this that right side. So minus becomes plus when we shift it to right side. So 1 by U plus 1 by F it becomes. And by applying the given measurements you have 1 by V is equal to 1 by U. U means how much? Minus 15. 1 by F, 1 by 10. LCM is 30. 15 ones are 15 twos are. So minus 2 because it's minus easier. 10 threes are. 3 into 1 is 3. 3 minus 2 is 1. 1 by 30. So that is 1 by V. 1 by V is 1 by 30, or V is equal to 30 centimeters. So what you got? Image distance is equal to 30 centimeters. What is the object distance? Minus 15. Okay. And then next question. What is the size? Magnification is equal to V by U, or image size by object size. 30 by minus 15, that is minus 2. Negative sign of the image indicates image is inverted. That is below the principal axis. Because the object is given above the principal axis. So image will be below the principal axis. It is a real image, inverted, and 4 centimeters tall. How do you get 4? Magnification equal to 2 into 2. Because the object is 2, height of the object is 2 into 2. Because magnification is 2. And why do you got minus? Minus because it is real image below the principal axis. And object is above the principal axis. Image is below the principal axis. So 2 into 2 becomes 4. So 30 centimeters from the other side of the lens. Image is formed is 2 times enlarged. Followed? If the object is 2 centimeters, the image will be 4 times or 4 centimeters. That is the meaning. So this is the answer for a question on convex lens. Okay. Now you shall see some home assignment. First question. Name the type of lens which always produces virtual image. Type of lens you must tell. Is it convex or concave? Second question. Differentiate between concave lens and convex lens. Third question. A concave lens has focal length of 15 centimeters. At what distance should the object from the lens be placed so that it forms the image at 10 centimeters from the lens? find the magnification by the lens. Come prepared? Thank you.